Hey everyone, my name's Nicholas Tate. I'm a engineer at DigitalOcean. Thanks for joining me today to watch this tech talk on the App Spec for the app platform. I just want to do a couple bookkeeping things before we get started. This talk will be recorded and it will be available on both the DigitalOcean YouTube channel as well as do.co/tech talks, so you can view it at any time after if you can't attend the whole talk or you happen to miss it the first time around. And then also, at any time, if you have questions, feel free to add them into the comment section. We're going to be doing a Q&A at the end, and then I also have another engineer here who I'll introduce in a second that's going to be answering some of those live in the comment section as well. So yeah, let's get started. So like I said, I'm an engineer at DO. I currently work on the app platform team, and I previously worked on the Kubernetes team at DigitalOcean. And we also have Kamal here today, who's also on the app platform team, and he'll be moderating for you in the comment section and at the end in Q&A. So let's start off. What's an App Spec? If you're familiar with App Platform, this is our platform as a service offering. And you can go and you can create these applications in the UI. And if you've ever navigated to the settings page, you might have noticed, this section at the bottom, and it says, your app topology is defined by the App Spec, and it can be used to edit advanced settings. So that's kind of what we're going to spend pretty much all of today talking about. And to kind of start defining what an App Spec is, you really need to understand what components are, because the App Spec is really just a wrapper for all these individual components. And it's really important to note that components are that's your actual application instances that are running, or the individual like microservices in your app, and they're deployed together, but they're scaled independently. So you can have one component that has one replica, and you could have another component that might be a larger instance size, or has like 10 replicas, for instance. But the key part is anytime you update one of them, your entire application gets redeployed. So component types, these are the different ways you can represent the application that you're running. So services, this is the main one. This is something that is routable, or you're exposing a port on, and specifically it not necessarily publicly routable. We support both internal and external services, and we'll talk a little bit more about each of these later on in the talk. Static sites. This is very similar to services, except that during the build process, you actually pre-compile your assets, and then we upload them to DigitalOcean Spaces and serve them behind a CDN. Workers, this is a component that's not actually exposing any port so you can't route to it, but it's really good for anything that you would need for like a background task. Maybe you have something consuming from a queue or something like that, but you really don't need to have any routable access to it. Jobs, self-explanatory, but this is basically a component that runs a job once to completion. And the key part is these are tightly tied with your deployment lifecycle. So basically you can run these, before deployment, after deployment, and we'll kind of go into more of these use cases later on as well. And finally, databases. So in your app spec, you can define database components that you can connect and use from other components within the app. So when we're talking about components, one of the key parts we need to discuss is, where do we actually get the content from? Because a component's nothing without, the underlying source code that you've written to actually like power it. So there's a couple different ways you can specify the source for your given component. There's a Git source, a GitHub source, and an image source. So we'll start out talking about the Git source. This is, referencing a public repository, or, a Git repository underneath the hood. And, it's only for public. You can't do private repositories. That's kind of what will save the authenticated GitHub source that let's talk about in a second. But if we take a look, and as a preface, I apologize for the extreme amount of YAML that we're going to have throughout this presentation, but it's a kind of a necessary evil when describing the app spec. So right here we have, this is a live app spec that you could go and run. And I'm describing two services. And both of them are describing a Git source. And you can see here that all you have to do to describe a Git source is specify the repo clone URL and the actual branch. And this is what we're going to use when we go and resolve the actual code that we use to build your application. Excuse me. So, you know, you're going to have use cases where you can't always have a publicly accessible like clone URL that you want to fetch your source code from. And that's kind of where some of the GitHub sources that we'll talk about in a second come in. But before I talk about that, I want to talk about the do deploy button, because the do deploy button, you know, it's tightly tied, you know, to the Git source in general. And this is something we released really recently at the DigitalOcean Deploy conference. And you can actually specify a template file in your repo and then enable your users to launch an application, you know, with one click of a button. And I want to mention it now because we're going to be talking about everything under the hood about the spec as we go forward. But the do deploy button, all it is really is an app spec keyed under a top level spec variable. And you can see here, it's defining a service, and it has a Git URL. And normally you'd want this to be, like I said, the public Git source, because if you had it to be a GitHub like private source, like we'll talk about on the next slide, then your user would already have to be authenticated to that repo. And that's generally something you don't really want to use the do deploy button for. So GitHub source. This is what a lot of you are probably going to need for any kind of like proprietary code that's not open source. And it's what we call an authenticated source. So you can use it for public repos as well, but you know, it's really used a lot for private repos that you need to have that, authenticated experience with. So if we look at this app spec on the right, you can see the definition is really similar to the Git image source. And instead of specifying a repo clone URL, you actually just specify the repo, because we already know how to resolve the host for this specific type since we know it's a GitHub source. And then just like the Git source, you specify the branch, but you get the additional configuration option of saying whether or not any updates to the commits at that repo actually cause a deployment to automatically trigger on the app platform. So one thing you're probably wondering is, you know, you can authenticate with private registries, but I don't really see any authentication metadata information here in the spec. So you actually don't configure this in the spec. You have to configure this outside. And it's basically an OAuth flow that you traditionally see when delegating access. So if you go on the app platform in the create app or the create component flow, you'll see here this configure your GitHub permissions button. And if you click on that, it's going to take you through a really standard OAuth flow where you sign into your GitHub account and you configure which repositories you want to grant access to the app platform for. Once you've done that with a repo or any of the repos that you want, you can specify them with that GitHub syntax in the app spec. The final source I wanted to talk about is the image source. Oh yeah, and sorry, on the previous slide, I wanted to mention we actually do have GitLab support coming very soon. It's not out yet, but it's in the near-term roadmap. So image sources is where you have a pre-built container that you bring for your app spec right out of the box. So in this instance, our build process isn't going to run and do anything to the source code. You're already going to have a pre-built container to run on the app platform. So right now we support DOCR registries, which is DigitalOcean's container registry service. And we do have Docker Hub support for public images coming soon. But I think this is a really powerful feature, especially if you already have pre-built containers in your DOCR registry, or even maybe a build pipeline setup already publishing containers to your registry. You can really easily connect them to the app platform. All you have to do right here is specify your image source for your component, where you specify the registry type as DOCR, and then you would go ahead and specify the repository and tag for that image. Obviously, the repository and that tag have to exist in your DOCR registry. If it doesn't, it's going to fail the deploy step, but the UI will promote that error messaging and feedback back to you, so you know when it fails to pull the image if it didn't exist, for instance. So we talked about image sources. The next thing I want to talk about is, we have the source code. How do we actually build that? And on the app platform, there's really two main types of builds. There's cloud native Buildpack builds, which is it's a really popular cloud native computing foundation project. If you haven't heard of it, definitely recommend looking more into it. I won't go into details on how it works, but just kind of how we use it. And then also Dockerfile builds via Kaneko, which is a cool tool that lets you build Docker containers without actually interfacing with the Docker daemon. So before I get into the individuals of each of those, I want to talk about a configuration option for your components that's common between both of those different build types. And this is the source directory of your build. So if you've ever had a monorepo or maybe a repo with an atypical directory structure where the bulk of the code you want to build isn't at the root of the repository, this is going to be your main key to choose exactly which directory the build occurs out of. Now, it's really important to note that you can have this source dir set on a per component basis. So if you do have a monorepo with, let's say, an API in the /API directory and then the UI in the /UI directory, you could have each component specify a different source directory with the same either Git or GitHub source that you reference, and it would correctly enter the directory you specified for the source directory as you build the application. So you can see here, I have an example service, and this is the spec for it, where the source directory I'm specifying as API v2. So once we clone down this repo and we initiate the build process, it's going to start that from the API v2 directory, not from the top level root directory of the repository. So kind of going back to the actual builds, like I said, we have two different build types, cloud native build packs and Dockerfile builds. So by default, all of the builds you do, if you don't do any customization to the app spec, are going to issue cloud native build pack builds by default. And you have a couple configuration options you can choose about how that build pack runs. And the main two that we'll talk about are build commands and run commands. So right here, you can see you can override both the build command and the run command for a particular component. And what's going to happen here in the case of the build command is it's actually going to go and append this as an additional command that it runs after the standard Cloud Native Build Pack runs. So when Cloud Native Build Pack runs, at a high level, it detects what type of language your application is, determines which build packs are going to apply, and then has a preset list of build commands that it runs and determines how to build the actual artifacts of your application. When you add an additional build command here, this gets run after the entire process. So I use this example of go build and then the current context directory, just because to kind of point that out. So you normally wouldn't want to do this because the actual Golang build pack is already going to be building the Golang binaries, and your build command is just going to duplicate those efforts. So unless you're doing something more interesting or you need to customize it from what the default build pack gives you, then you're not really going to want to set an override for the build command in those instances. The run command, though, does actually override the entire run command. So this is the command that we use when actually running the OCI container that gets outputted as a result of the build process. So the other version is Dockerfile builds. And like I said, by default, Cloud Native build packs are going to be the version that's run, but you can, if you already have a Dockerfile, specify a path to that Dockerfile to trigger our platform to use your Dockerfile in the build process. And the way you do that's really simple. All you have to do is specify a Dockerfile path. So if we take a look here at this app spec, you can see at the bottom there, I'm defining dockerfile.apps as the path, and this is relative to the root of the repository that you're cloning. So in this instance, my build's actually going to, skip using Cloud Native build packs to determine the language and run it. It's just going to follow the execution steps in that Docker file that I'm referencing to build the container. And then similar to Cloud Native build packs, you can also override the run command to determine how the container runs. So, we've defined where the code comes from. We've defined, what processes what processes determine how the build occurs. I want to talk a little bit about caching. So caching really happens at 3 layers on the app platform. There is what I call app platform level caching, and then also build level caching of both Dockerfile types and the Cloud Native build pack types. So when talking about app platform level caching, what does this mean? So every time you build a component, or we build a component on your behalf, there's actually a unique key associated with that. There's a kind of three inputs to that key. And the first is the internal builder image version. So this key is, you don't really get access to it at this point, but this is the underlying image we're using to facilitate the build. And periodically we do go and update this builder image. The source commit hash, this is going to be what your repo and your branch resolve to. And then finally, the app spec fields. So it's this combination of all three of these that determines the uniqueness for a component. And if we can determine that all of these are the same between one deployment and another for a given component, then we skip the build process entirely. And this is really powerful and can speed up your builds a lot, especially when you're not modifying things that can affect the build process of your component. So I talked about app spec fields, and you're probably thinking, if I change anything in the app spec, does that really trigger an invalidation of the cache for the build? And it's not everything. So only things that affect the actual build process will cause a cache invalidation. And examples of exceptions would be runtime scoped environment variables, which we'll talk about in a little bit and go into more detail on how you define that. Instance count and instance size slugs. So if I'm just changing the number of replicas for a given component, that's not going to cause a cache invalidation. Run commands is another example. If you're just changing the run command that gets applied to the container that you built, it's not going to actually trigger an invalidation either. And there's a lot more of these, but the general rule of thumb is, if something would affect the build process, then it'll cause an invalidation. And if it doesn't, then we won't. And I don't know if there's any documentation, and I think I can put an internal ticket in to kind of get a list of all of the exceptions for this. But if you ever do find any fields that you think shouldn't really affect the cache invalidation, please reach out on the DO community site, and we can look into that particular field and see if it does make sense to put as an exception. So now we're going to move on from app level platform caching to the actual build process caching. And I'll talk about the Dockerfile one first. And I'm not going to go into a lot of detail on the actual techniques you use, but I am going to give a quick example of how you can better take advantage of caching for your Dockerfile builds. So if you're familiar with Dockerfiles and how they work is each step kind of runs and then takes a snapshot in a layered file system approach. So in this example, these two steps here where I'm copying all of the data from the repo and then I'm running the actual Go build of the application to create the binary. This isn't really going to be able to determine nuance of what file has been edited. Anytime any file in the entire repository is edited, it's pretty much going to invalidate the entire Go build and everything's going to have to run again. So something you might want to do if you're trying to optimize it is take advantage of the dependencies. So in this example, I'm specifically copying in the Go mod and the Go sum file separately and downloading the dependencies before I actually copy in the rest of the files from the repository. And this gives you the advantage where if you only change something and let's say you have a main.go file and you don't affect any of the dependencies stored in the Go mod or the Go sum, then you're going to be able to reuse all of the layers before that. So it's going to be all of the dependencies that were downloaded as part of the previous Dockerfile build. Like I said, there is a ton of great resources out there and blog posts on how to best optimize your Docker files. So definitely check that out and make sure you're taking as much advantage of that as you can. So cloud native build packs. The caching on this side is a little bit easier. It's on a per build pack basis. And there's what's called the analysis phase of the CMB lifecycle determines if there's any layers that it can reuse in the subsequent build. And you actually don't need to do anything on your end. If there's something that's able to be cached, it will be. And the good thing is as app platform matures and a lot of these build packs mature, hopefully the actual caching support and all of these build packs improves as time goes on as well. So now that we've talked about that, I think it's a good time to kind of talk about environment variables, because I said that was one of the particular fields that by default is going to invalidate your app platform cache, but it's something if you tune a little bit more, you can actually take advantage of ones that only belong in runtime to help cache your components more when you're changing stuff that doesn't affect the build phase. So we're going to talk about three different parts of an environment variables: scope, type, and templating. So scope, this really is referring to the availability of that environment variable during the different deployment phases, which are the building phase and the actual deploy phase. And like I said, this is really important for caching. If you have an environment variable that you know is not used in the build phase, you definitely don't want to allow it to be used in all phases, because anytime it changes, it's going to invalidate that cache. So if we look at this app spec on the right, the first example is what typically happens if you've ever created an environment variable through the UI. By default, if you don't set the scope or you set it to run in build time, it's going to be available in both the build and run phases. So if you have an environment variable, let's say a port that determines where the application binds to at runtime, and you change that, even though it has nothing to do with the build phase for your application, it's going to require the entire build to occur again. Now, you still will gain advantage of the either individual Docker file or cloud native Buildpack caching, but we ideally don't even want to enter the build process if we know we can reuse the entire container we created before. So that's where the scope comes into play. So you can set either only runtime or only build time for a given environment variable, and then that's going to be available in one of those phases accordingly. So the next up is type. So this is mainly to distinguish between kind of the plain text or sensitive values in your environment variables. And it's really important if you do have sensitive values that you set the type to secret for them. So if you look here, by default, unset or general, these are going to be equivalent. This is for your plain text values. Nothing special happens to these, and they'll just be injected into the different phases depending on the scope set for them. But if you do have a sensitive value, you can actually set the type to secret. And this allows us to know to encrypt this value when we store it in our database, whenever we have it stored in the Kubernetes cluster. And eventually we decrypt it before we mount it into the actual container for use. So if you actually submit this app spec to the app platform or update an existing app with this, you'll notice on the return value, when you get the app spec back, it's actually going to have the encrypted value. And this is really important. You want to keep resending this encrypted value if you want to have the environment variable stay and not change. If you ever do need to actually update that encrypted value, if you change that to a plain text value right down here, that'll actually go and re-encrypt and do it again. But like if you send this encrypted value again, we're not going to re-encrypt the encrypted value. It detects that it's already encrypted and it leaves the value untouched in all of the updates. And last but not least, the other field you can control with environment variables is templating. So templating, if you're familiar with handlebars or something like that, it's a way we can reference dynamic data. And in our case, this is going to be for the environment variables on your components. So it's a cool feature and it's really powerful because you can actually reference these dynamic variables from any components within your application spec. And you can even chain multiple ones of these together in a single environment variable. So I have a couple examples here in this app spec. And if we look on the right, the first one is actually defining the bindable variable public route path. And it's saying it wants to grab that value from component web2. So what happens is when this gets injected into your container during whatever scope it was set for that particular variable, it goes and it pulls the /web2 path from the other component that we have defined. You can also reference the existing component with _self. This is really syntactic sugar for, in this case, would be web, but it just references the current component that you're on. And in this case, this would resolve to the commit hash of the current component. And then finally, this is showing that you can mix, literal values, you can mix other component bindable variables. You could even have multiple bindable variables on the same line. And all of these are going to get resolved, and it'll resolve between that $ open and close curly brackets. So now that we've talked about a lot of the common fields between the different component types, I want to go into some details about some of the more specialized component types and the different options you have with them. So we talked at the beginning a little bit, and I overviewed jobs, and I said it's a unit of work that's run once to completion, and it's tied tightly to the deployment lifecycle. So you can actually specify 3 different conditions for when a job runs. You can run a job before your deployment deploys. So this is after the build phase, before any of the other components actually get deployed, all of the jobs with pre-deploy will run. Similarly, you can run post-deploy jobs, which will run after all of the non-job components finish deploying. And then the final one is failed deployments. So, failed deployments will run anytime you have an unsuccessful deployment. So this would be useful if you had to do like a rollback for a database migration or something along those lines. So databases we also talked about. There's really 2 different flavors of databases on App Platform, and we call them either dev or production databases. So a dev database is a really special database that you can define on the App Platform only, and it's a really small, cheap, limited database that you can launch without actually having to do any management in the DigitalOcean database service. So right now we only support Postgres for our dev databases, but it's really cool because if you do create a dev database in Postgres on the App Platform, you can actually eventually promote that to a production database later down the road if you end up needing to increase the capabilities of that database. So if we look, defining a database is pretty easy in the App Spec, especially for the dev database. All you would do in the database section is set production to false. And then, in this case, since we only support Postgres, you have to define the engine as Postgres, which is the type of database, and then the given version. And then right here, we're naming our component called database. And you can see in the actual service, then we have the bindable variables associated with the database to reference. And it's as simple as that. So then during the deployment lifecycle, it's going to make sure that the actual databases are created and up and running before it continues on to deploy the other services in your application. And the other type of database is production databases. So these are a little bit different and need a little more manual configuration and setup. And basically, these are databases that already exist on your DigitalOcean DBaaS instances. So you'd have to go outside of App Platform, create a DigitalOcean database, and then you can reference it in an App Spec and connect to it. And the key field when you're referencing a production database is, well, there's really 2. You set production equals the true in that particular database component. And then you also have to specify the cluster name. And the cluster name is the actual reference to what you named the cluster when you created it in our DBaaS service. Once you do this, you do get a little more configuration. You get all the power of the DigitalOcean database service to configure and modify the database as you see fit. And then you also get to choose what's the database user, what's the database name, and some of those other configuration variables for exactly how App Platform connects to and populates those bindable variables for use in your other components. So static sites. We said that these are really similar to services, except that we pre-compile the assets and upload them to spaces. So one of the really important things with static sites is what exactly are we uploading to be served by the CDN? And by default, those 4 directories listed there are the ones we look for after the build process to actually upload to spaces. And it's kind of cool. We try to be a little bit smart about how we determine this. So if one of these directories gets created during the build process, we actually prioritize that to any pre-existing directories. So that way, if let's say public directory existed at the root of your repository, but then during the build process, we created the dist directory, we would actually prioritize choosing the dist directory as the source of all the static assets to upload to spaces. But with this output directory command, you can actually configure exactly what directory we use to upload all of the static assets. And so if you have something that doesn't fit into this pattern that we've tried to define for the majority of use cases, you can configure that however you want to correctly upload your assets. Index document, I actually don't have an example of this, but it's pretty straightforward. And this is actually when, one of the routes matches what we're going to serve to the end user. And it's like the root document. I do want to talk a little bit about catch-all and error document. And I think these actually recently made it into the UI, but previously you could only configure them via the CLI and the API. So catch-all document and error document, these are really similar. They're actually mutually exclusive. You can only have one or the other. You can't set both on a given component. And basically what they do is they say, what document do I serve if a route doesn't match one of the ones I've defined and I can't resolve it. And they work in very similar way, but they change the HTTP response code that returns as a result. So the error document is going to return a 404 if it hits a route that it doesn't know about, and the catch-all document's going to return 200. So you might be thinking, what would I use a catch-all document for? Why would I want to return, a 200 if a user hits a route that doesn't exist? And this can be really useful for things like a single page application where a lot of the routing is handled client side, but you just want them to keep redirecting the index document to be served for them. And right here, these are just the two examples of each. It's pretty simple to configure. It's just the one key that you set underneath the component for either catch-all or error document. So we also can configure some basic CORS abilities on the app platform, and this is applicable to both services and static sites. Internally, we're using Istio for a lot of the ingress routing, and basically these end up getting mapped down to Istio virtual service CORS policies. And right now we only support allow origin, but definitely if you have use cases, please reach out in community. As we get feedback, we might be able to put on the roadmap, supporting different types of CORS policies through the App Spec. So if you look here, defining a CORS policy is pretty simple. There's actually three ways. I only have two listed. You can either define an exact match for your origin, you can define a regex match, or you can actually just define a prefix match as well. And this is going to set the actual allow origin headers on the responses for your particular component. So health checks. Health checks are actually available by default, or they're actually enabled by default on all your services. And they're going to be a TCP health check, and it's going to hit just the standard HTTP port that your application is defined to. And there's a lot of configuration you can do. The UI right now, I believe it only allows you to specify whether or not it's a HTTP health check or a TCP one. But there's more you can configure under the hood if you're working just with the App Spec. So you can set the initial delay seconds. So this is important. If you have an app that doesn't actually bind and isn't able to serve traffic on the port it defines until some startup amount of time has it expired or passed, then this is something you can set for your applications to delay when the first health check gets issued. Because if you don't have this set and your application's not actually listening or not ready to respond on that port, then the deployment's going to fail, and it's going to fail out of the health check after the threshold's crossed. Some of the other things you can set are period seconds, which is the time between subsequent health check pings. The timeout, self-explanatory, but this is the amount of time until that the health check has to respond on in order for it to be successful. And then finally, the success and the failure threshold. So these are two thresholds for how many instances of a successful or a failure before we end up marking it as healthy or unhealthy. And I really want to promote, you should keep these as low as possible, especially in terms of feedback cycle, because you don't want your application to take like 2 minutes to determine if it's healthy or if it's unhealthy. It's really going to slow down the deployments. But you do have the power to tune these as you need if your application has some characteristics that don't really match the default ones. So, we talked about at the beginning, you can have internal versus external services. And the way you do that is by defining an internal ports array on your app spec. So by default, all the services are going to be externally available services. And in order to go and make it an internal service, all you have to do is say which ports are internal and don't define any like public routes or any public HTTP ports. And when you do this, you get to actually route to this from any other components within your application. It's not available from other applications. It's only the components within, and you can use this private domain bindable variable from the templated environment variables we talked about earlier in order to actually access it. So if I take a look at this spec, it's a sample spec defining two components. We're defining one service and we're defining one job. And the service is actually defining this internal port 7777. And I'm defining the environment variable there because that modifies, what the application actually decides to listen to. If you were paying attention earlier, I should have added a scope for runtime only, because anytime I change that, it's going to cause a build cache invalidation. But yeah, so if you look there then at the job, I'm creating a post-deploy job. And this job is actually referencing the other internal service on the private domain. The service is named in, so this is that bindable variable syntax where I have the component name followed by the name of the bindable variable. And then I'm referencing port 7777. So when this runs, after that internal service successfully deploys, it's going to go and this job's going to run and just echo the curl output of curling that route for that service. So this is super useful if you break up your applications, and maybe in like a microservice oriented approach, and you have an internal API that shouldn't be accessible on the internet, and you might have a public API. You'd want to make the internal one an internal service in our instance on the app platform. So last but not least, I wanted to chat a little bit about domains. So all of your applications, and I think it's like one of the really cool and powerful features of App Platform, they get a default service ingress. And this gets applied after your first successful deployment on the App Platform. And it's an automatically generated domain secured by TLS that you can use to route to your application. The part we add on to this is you can actually specify custom domains to configure for your application. And these can be of two different varieties, which we'll call delegated versus external. And we'll go on to talk about delegated first. And this is really where DO is managing your records. So it's kind of a hands-off approach other than a one-time setup where you have to actually update your registrar to point that zone to DigitalOcean's name servers. And once you do that, we can actually manage all of the records on your behalf, and you get some pretty cool features out of it. So, DigitalOcean delegated domains, they support wildcard domains, they support Apex domains, which is also known as root domains. Generally, this is good for new zones that you don't already have configured somewhere else, because if you do, you are going to have to run into the one-time burden of transferring all the manual records over to DigitalOcean service. But once you do that, the app platform can create and manage all of the records for your given zone on your behalf. And if we look here, specifying this is really simple in an app spec. It's a top-level domains array. And what you do is you specify the zone. And this particular key, when you specify the zone, in this example as nicktate.app, that's really telling our app platform reconciler that this is a delegated domain that DigitalOcean is supposed to manage. The actual domain you specify that you want to route to the application, it could be an Apex domain, in which case I would have it as just nicktate.app. But in this example, I'm using a subdomain of mydomain.nicktate.app. And you can also say whether this is a wildcard domain that you're supporting, versus it just being a specific subdomain. So one thing to note is I did say that there is one setup step of pointing your zone to those DNS name servers. Generally, you're going to want to do this before you apply the app spec, but our reconciler will try to intelligently re-reconcile the domain at increasing backoffs. So if you did, for instance, have the nicktate.app pointed to Cloudflare name servers or something like that, and you applied this spec, it's not going to be able to resolve correctly until you do update those name server records to point to DigitalOcean's name servers. And the final part about domains I want to talk about are the external ones. So this is where you have your own provider managing the records for your domain. It's a little more setup that you have to do because every time you create a new domain, you're going to have to do or create a new CNAME record on your provider to point to the app default ingress that we talked about a little bit earlier. And the feature set, it's really limited depending on the actual provider. So not all providers support Apex domains because this isn't part of like the standard DNS spec. But if they do support it, you will be able to use it. An example of one that supports it is Cloudflare, but you really have to look into each provider to determine it on a as needed basis. And the spec for an external domain is very similar. The key part being we're omitting that zone key that I talked about earlier, and all you're doing is listing the actual domain you want to reference. And like I said, I'd have to go on my provider and I'd have to create a CNAME from mydomain.nicktate.app to the actual default ingress of the app. And that's it. I know we went over a lot of stuff. I have two references here. One's for the actual app specification. We talked about a lot of different fields in the app spec today, but there's a ton more that I didn't go into detail on. And you can always go here to see a reference of all the available fields and all the customizations you can do. And every time we release new stuff, we're making sure that we keep this up to date. And then there's a lot of bindable environment variables that you can use as well. So I reference to another product doc page that lists a lot of the different variables that you can use in your different components in your app spec. So with that, thank you for tuning in. And right now I'm going to have Kamal jump on. He's another engineer on the app platform team, and he's going to help or send any of the questions my way that you guys have been asking in the comment sections. So thank you.
Thank you, Nick. So we had a couple of good questions in the chat. I'm going to walk through them in order, and if anyone thinks of any other questions, please type them out in the chat and I'll read them out. So first, we had a question: what are some examples for job components? What are some use cases for jobs?
Yeah, good use cases for jobs. What generally comes to mind are database migrations. Maybe you have a pre-deployed job that triggers a database migration, anytime your app needs to be deployed, especially if you have a schema update for the given database. And similar, if you handle kind of rollbacks, if you have a failed deploy, there's probably going to be a rollback to the previous database state if there was a migration that occurred. So you'd want to use the failed deployment job to do a rollback in that instance.
Awesome. Another question was, when I add a database component, it automatically adds an environment variable, but it seems like the connection string is wrong. Is it a bug?
I'm not 100% sure on that. I guess it depends exactly on how you're using the connection string. So we actually add I think the default database URL environment variable. Yeah, I'd have to follow up on that. If you do see a problem with that, please reach out or add the question on the community channel with a little more detail on exactly what situations are arising. I don't know if you have anything else to add on that, Kamal, but I don't know about that one off the top of my head.
Yeah, that pretty much covers it. The default environment variable that we add is a bindable environment variable. So definitely check out the link in the references slide at the end. It's also in the description of the YouTube video and the Facebook Live. There's a resources link. So you'll see the slides there and the references there as well. Another question that we got: can you speak to App Platform's integration with other abstracting layers like Kong and HashiCorp tools, ingress controllers, and other externals like AWS, GCP, etc.?
I think I might ask for that question to be clarified a little more on exactly how we integrate. So we integrate with a lot of open source tools on the app platform. We covered a couple of them, being like cloud native build packs and Kaneko for the build process. I think it's public knowledge that we're using Kubernetes under the hood and using Istio for our ingress gateway. So we are leveraging a lot of great and proven open source technologies for different parts of our our platform. But as far as specifically integrations with like AWS or GCP or something like that, I'm not really sure exactly what you mean by that, but we don't really have any integrations today for those.
Cool. The job asks for a repo. So do you have to make a single repo that just does the DB migration and edits the job? Or is there a different way to do that?
So, in this instance, the job doesn't necessarily ask for a repo. So this is just one of the sources. So you could even specify, a DOCR image source if you had a pre-built container. One of the things you could do is create a subdirectory in your main repository that has all of the code to create the job, and then use that source dir that I mentioned in the build phase, so that you could have a separate environment for actually what builds the database migration or wires that up for your container.
Yeah, and if you also have like a single shared code base for your actual web app and the database migrations, for example, like a Laravel application or similar, you can reuse the exact same repo for both the service and the job. Just make sure to set the right run command on both. So on the service, you set the run command to start the web server, and on the job, you would just change it to run the database migrations and exit. So that would also work. It just depends on how your app is set up. That looks like it for questions in the chat. Yep.
Give it a couple more seconds to see if any other questions come in.
Okay, we got another question. The React example or sample app has two YAML files in a .do folder, but neither seem to affect the default new component state after inspecting the repo. Is there a reference for these files?
I'm actually not familiar with what the React sample repo is set up with offhand. Do you know, Kamal?
Yeah, so I believe the two files they're referring to is the .do/app.yaml and .do/deploy.template.yaml. So these are two separate files. The .do/app.yaml does not do anything. It's just there like a standard path if you wanted to store the spec in your repo, but it doesn't affect your app. It doesn't really do anything. Just a convenient place to store it if you wanted to. But the deploy.template.yaml file is part of the deploy on do button. And there's a page for it in the product docs page. I will post the link in the chat right after this. But it configures what kind of app is created when you click the deploy on do button. And it's so the deploy.template.yaml accepts a whole, like a complete app spec in it. Right now, it's only limited to one component. The limitations are written down in the product docs page, so definitely check that out. And then another question is, can database ports be restricted to app instances and not be public?
So that's not currently supported today. It's very high on a roadmap. I don't have a specific timeline, but it's definitely something we're working towards providing a solution for in the near term.
Okay, another question. Being really active today, this is awesome. Is DO a hybrid cloud hosting solution?
So so the app platform itself all runs on DigitalOcean infrastructure. So it's running on top of Kubernetes under the hood. So it's not really a hybrid cloud solution per se. It's all running within DO's environment or ecosystem.
You mentioned DNS is managed by DigitalOcean after transfer. Can we still add our own records as well for other non-app platform things?
Yep. Yeah, the app platform is only going to manage the records created by it, but you could go into the networking domain product for DigitalOcean and add, custom records for whatever you wanted. All right, I think that's all the questions. But yeah, I want to thank everyone for tuning in today. If you have any more questions, please reach out. We're really active in the community channels if you post any questions on there. So yeah, thank you, and I hope you learned a little bit more about what defines your application and a little bit more of the customization you can do under the hood if you're not working directly in the UI. So thank you, and thanks Kamal for helping moderate this today too.
Yep. Thank you, Nick, and thanks everyone for attending.